Now, P of t represents the population of people at school t hours after 10 a.m. P of t is a quadratic function, so this is important. Everything's referenced from 10 a.m. as being time 0. 10 a.m. is your time 0, so that's going to be a little interesting. And also this is a quadratic, meaning it's a parabola. Now, are we okay if the population of people at a school, is it probably going to be a parabola that looks like that? Do you think it's going to be a parabola that goes up? So that'll be important. So what's going to happen here is for problem 1, we're going to look for the equation, P of t. All right? But before we do that, let's draw a quick little sketch. All right? Now, we're going to make a sketch, and we're going to make 10 a.m. I said 10, sorry. 10 a.m. is your time 0. 10 a.m. is time 0, and we're going to make a quick little sketch. So, write a function P of t, population, that has no one at school at 7 a.m. and 9 p.m. So watch this carefully. Are you okay there'll be no one at school at 7 a.m. nor at 9 p.m.? Are we okay? We're making a dot here at 9 p.m. and at 7 a.m. 10 a.m. is your middle, is your axis. Now, if I have 2 dots, isn't this called intercept form? Can I make an equation with 2 zeros? But can I first convert these into positives and negatives? Meaning, 7 a.m., how many hours before 10 a.m. is 7 a.m.? Is everybody okay with 3? Are you okay that's a negative 3 technically? Is everybody cool with that? If you're at 10 a.m., isn't that 3 hours earlier? What would 9 p.m. be? Be careful.
11 hours later.
It's 11. I'm going to put a plus 11. Because think about it. 10 a.m., if 2 hours, you're at noon, and then it's 9 more hours. So 9 plus 2 is 11. So you first got to understand your clock. Are we okay? This is a negative 3 intercept, and this is a 11 intercept. Can we make an equation? Watch how this works. It's pretty simple once you think about it. Are we okay? It's an upside down parabola.
Yes.
I don't know what A is, so I'm just going to put negative. Since I don't know the actual value of A. You can put any value you want as long as it's negative. Then I'm going to put T. Okay, my time. Now I need my X-intercepts here. Do you guys, if we have negative 3 and 11, what are going to go right next to these for intercept form? Remember, it's opposites. Good, some of you got it. Opposites, so it'll be a positive 3 and a negative 11. So this would be a possible function for this situation. Now, if we knew how high this was going, could we maybe find A? If we had more info, I could find A. All I know for sure is that it's a negative. I don't care what numbers are. Now, I do care about these two numbers. Those numbers have to be 3 and negative 11 because that's how you get the intercepts. Now, these two problems in a second here, this one's going to be either vertex form or standard form. So you got to figure out which one's which, and it's going to be the same concept in a second here. Now, for this one, I did forget to, remember, it's a quadratic, so what would the graph look like going through those 2 points? It'd be a parabola upside down. So hopefully you're okay. It looks something like this. Now, do we know how high it is? Is there any way to telling the vertex of this, the maximum? No. So that's why we don't know the actual A value. All we know is it's negative. We do not know if it's negative 4, negative 8, negative half. We just know it's a negative. Now this problem right here, write another function P of t where the largest population is 2,000 people at 12 p.m. Now if I'm thinking of a parabola, largest population at 12 p.m., largest, isn't that called a maximum? And isn't a maximum called a vertex? So that should in my mind go, oh, I need vertex form. So first of all, I'm going to be making an equation, P of t. And we said vertex form. Okay, we'll come back to that. Now, if I have my axes, we know 10 a.m. is here again. Through the whole problem, this is 10 a.m. That's a great 10. There we go, 10 a.m. Now, it's saying 12 p.m. Are you okay? 12 p.m. is right here. And is 12 p.m. Positive 2 or is that a positive 2 over from 10 a.m.? Is that 10 hours past 10 a.m.? Sorry, is that 2 hours past 10 a.m.? Are you guys okay that 12 p.m. is 2 hours after 10 a.m.? So I could call that a plus 2. Now, do we know that my vertex is going to be somewhere up here? And are you okay? It's 2, that's 12 o'clock, 2,000. Isn't my output 2,000 high? A population of 2,000 at time 2. At time 2. Do I know anything else besides that? I do not know anything else. All I know is there's going to be some sort of parabola that looks like that. I do not know the X-intercepts. Okay? I don't know my full A value. I just know that. Okay? So, but I can make a vertex form with that piece of data. So let's write vertex form. Don't I know it's negative because it's upside down? I don't know what my negative what. It could be negative any number. Just put negative. That's all I know for sure. And then, but vertex form looks like this, doesn't it? And that's a t because we're not dealing with time, not x. So is it going to be next to that t a positive 2 or negative 2? Is it a negative 2? Is it an opposite of my x value of my vertex? So won't that be a negative 2 in there? And then won't the 2,000 be my k? So that doesn't change, so it's just 2,000. And that's all we're looking for. What we're looking for is to put the vertex into vertex form and be aware of this is negative. Again, we cannot tell the exact value of that in front. So there we go. That's all it is. So for this one, write a function p of t where 1,500 students are at the school at 10 a.m. Now, isn't 10 a.m. give you a little deja vu? Isn't 10 a.m. your 0 time? Oh. So if we graph this, we know this is going to be p of t. If I graph this, well, if this is 10 a.m., and if I know at 10 a.m. it's, well, if I know that's 1,500 people, isn't that on the y-axis? Isn't that called a y-intercept? So if that's all I know, right? Well, couldn't the parabola look like anything through that point? It could do anything. So would it maybe look something like that possibly? I don't know. But what I want to do is I want to create an equation that could go through that point. So the best option is standard form. That could go through that point. Now I'm going to label that point as 0, 1,500 or 1,500. That is the only point I know about this parabola. I do know it's upside down just because it wouldn't make sense to be a happy parabola. That would make no sense for the situation. But for this one, so I know it's going to be a negative x squared plus, I don't know my x, so just let's put x. I don't know what the b value is. There's no way to know my b value. But do I know my y-intercept? Yeah. I actually do know my y-intercept. So this could be plus what? 1,500? Now, I did think about something. Is it possible for this one to actually go like this? You don't know what the school looks like. It actually would technically be possible for this to go down and back up. Got it? But for these benchmarks, let's stick with upside down parabolas. It is possible for this one technically to be going down and back up. Okay, it wouldn't make sense for this because isn't this a maximum? So you have to have it as a top. And for this, if these are X-intercepts, would it make sense that it's going with negatives all that time? For this one, you technically could have a graph that goes like that and back up. We don't know. But let's go with a negative a value. Again, we don't know b. B is still, we're just assuming a b as 1.